Hi, my name is Micah. I go by Micah Scopes on GitHub, um, and I'm from Minneapolis, in the U.S. And I'm kind of a creative technologist. And recently, I created a visualization for the DAT ecosystem to explore relationships between all the different projects and packages um, that are woven together in the DAT ecosystem to create all kinds of distributed web and peer-to-peer web projects. So you can find this project. It's called Webscape Wanderer on GitHub. Um, it's at microscopes/webscape wanderer. And you can find this demo that I'm going to show you at the link in the project description on GitHub. And when you open it, when you first open it, it will look like this. And you can see if I hover around, there's a cursor that shows different projects. And let's find one to click on. Ooh, I saw an important one there. Hypercore. Okay, so when you click on a project in Webscape Wanderer, it will zoom in. And just for the record, I'm going to be sometimes using my fingers to navigate because there's touch navigation. And so right now, Hypercore is selected, and you can see all of the projects that are directly related to Hypercore. So the green cubes are dependent on Hypercore, and the blue cubes are dependencies of Hypercore is dependent on the blue cube projects. So for example, let's look at, what's this one? StreamX. So Hypercore is dependent on StreamX. And let's see, StreamX is dependent on, what's this one? Fast FIFO. I don't really know what these are, but it doesn't matter. And then, so Fast FIFO is also a dependency of this project here, DHT RPC, and what's this one? StreamX and Hyper Simulator. Let's click on Hyper Simulator. So you can see Hyper Simulator has mostly dependencies in this graph. So anyway, this tool is meant for exploration, at least in the current build, but I built the graph visualization engine kind of from scratch, at least from some pretty basic ingredients. And it's a very over-engineered project, the Webscape Wanderer. The reason being, I was pretty frustrated with the trade-off between flexibility and performance that I found in a lot of existing graph visualization tools. And so after a while, I just kind of decided that I wanted to start from scratch. So let's just glance at the features on GitHub, on the GitHub project. So some notable things, like we've got instance rendering. This is for performance. So basically the cube geometry is rendered using instance rendering, which that translates to high frames per second. There's a hash route based interaction. So what that is you can't see the URL bar, but if I use the back button, oops, or in this case the forward button, if I use the forward and back button, you can see that we're navigating through the path that we took, the history, and that's because there are hash URLs every time you click on one of these projects that can be used to navigate. Let's see what else we got going on. The data is actually stored in a graph database, a triple store database with Sparkle queries, and so there's a separate worker that does the queries. Yeah, that's kind of over-engineered. So anytime I click on one of these projects, there's a Sparkle query to find the dependents and the dependencies, and the interface for doing the queries is actually pretty abstract. So it could be used to visualize all kinds of relationships. Like, for example, you could visualize all of the upstream packages that a given project is dependent on, not just immediate dependencies, but dependencies of dependencies, dependencies of dependencies of dependencies, stuff like that. With the Sparkle queries, you could do whatever you want. The layout is actually, well, yeah, it's done in a separate worker. So the animation, or I'm sorry, the graph layout itself, like the positionality of these, these cubes relative to one another, is determined like in a separate worker so that it doesn't disrupt the smoothness of the experience. And similarly, the animation is also done in a worker. And as you can see, when I use the back button, the animation is dynamically interpolated based on the latest target. So if you set a new target, it should kind of smoothly start centering that target. You can see it better if I zoom in. And it's using like a spring animation kind of tween thing. Okay, what else do we got? Oh, the graph, like the colors and stuff, and the selection parameters and things like that are all interpolated and animated on the GPU. So like you can see when some projects are selected, they're larger. The sizes of the nodes are animated on the GPU. So it keeps things very smooth. All right, so that's kind of a basic list of features that are currently in here. I'll also show you. This is the fun part, if you ask me. If you press, so if you're on the computer and you press D on the keyboard, you can see the debug stuff, and that would be like the frame rate indicator over on the upper left, and then on the right there's a little GUI for playing with some of the shader parameters. So let's talk about the shader or shaders real quick. This is using WebGL. It's using Three.js, but it's not really. These are not Three.js objects. It's really just. It's using Three.js for like convenience sake, with custom shaders. Like everything is a custom shader, and there's some rendering tricks to make this kind of visually a little more friendly. I mean, from my point of view, to navigate. So, for example, the locally each each project is rendered as an isometric cube, but the global perspective is not isometric. So there's like some perspective effect globally, but if you zoom in, you can see that all of the projects are rendered as with a with the isometric perspective. So like orthographic perspective, and there's some like hacks going on in the shader to make that happen. But I really like how it turned out because I think it makes it a little easier to navigate. It's a little more stable visually. Like the cubes are easier to click. And when you zoom in, the cubes in the background get big. So it's not a standard perspective. Um, Also, the edges are rendered. Let's see here, edge scale. The edges are rendered as um, uh, polygons, and um, there's no depth. Uh, 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 I'm sorry. There's no Z information being used in the blending. So the blending is all just done like uh, uh, basically depth testing is disabled. So it gives this very kind of smooth, ethereal effect. And this helped with performance, and it also got rid of some artifacts. The depth testing was creating like some really weird, jarring artifacts, and when I disabled it, uh, it just made everything look smooth. So right now, I've cranked up the scale of the edges, and I really like how this looks. It's like it's ethereal. There's these. You can see the. It's almost like the information is being spread around uh, through the ecosystem like ripples in a pond or something. And yeah, I just love looking at it like this. Um, you can change the frequency of these edges. You can change the edge wave speed. Um, if you zoom out, it gives like a really interesting effect. There's also, to show directionality, there are these pulses that shoot um, between the nodes along the edges, and you can increase the pulse speed. That's another way of looking at this. So yeah, this is fun. Again, if you want to access this just on the computer, you press D to toggle. And if you're on a phone, if you tap the screen 4 times, tap, 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 it will toggle. Tap, 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 tap. And yeah, it's a fun way to kind of play with this visualization engine. Let's see. Is there anything else to show here? Yeah, I mean, it's just fun to see the different ways that the information can represent if you tweak these parameters. Okay, all right. I'm gonna get carried away if I keep playing with this. Um, I'll just talk briefly about some of the project goals. and you can look at this checklist on GitHub. I'd really like to generalize this so that it's usable for visualizing all kinds of graph data, not just dat ecosystem graph data. So right now it's pretty modularized, but there's not really an API yet, like to use this with generic graph data. So there's quite a bit of work to be done to design that API and make it nice. Some work needs to be done to support multiple instances of this renderer on the same page. It would be really cool if you could use this as a web component and even define the colors and stuff using CSS. I mean, that would be awesome. Let's see. This stuff is mostly about making a nice API. So yeah, if you look on this README, there's lots of details about like what I would like to see for a generic API. And if you would like to use this for something, please go to the GitHub page and make an issue, and let's talk about it. I would like to support more layouts, like and to have dynamic layouts so that you could animate between different layouts. Currently, it's totally possible to compute multiple layouts at once. There's just not an obvious way to animate between them. It would be awesome to have a GPU-based layout engine so that you could do huge graphs, or even like special embedding kinds of like things like tsne or stuff like that. That would be cool. Let's see, what else do we got? Oh, it would be nice to have more cooperation with Three.js. Like Three.js is really standard, and it would be great if people could use this with Three.js more easily. Currently, that's not possible. Let's see what else. Yeah, there's a lot of basic little improvements that can be done. Right now the iOS support's not that good, and I worked on some fixes for this, but there's more to be done. It has to do with the way that the animation is being handled. Like I'm using frame buffer attachments to do some of the animation, and iPhones don't support as many frame buffer attachments as I'm trying to use, so gotta go with a different route for that. But yeah, there's lots of stuff here. There's probably more that I didn't even put down yet. But I would love to hear ideas for how you might like to use something like this. A couple obvious things that I forgot to mention. It would be great to have different geometry for each node, like polygon models and stuff. And it would also be cool to have like a theming system so that you could make your own effects, your own render style for edges and nodes, like arrows or whatever. So, yeah. Thank you for checking out this demo. Let me know what you think in the Q&A. Or if you're watching this online, like, please come visit the GitHub project page and leave me an issue. And that's it for now. Yeah, thanks for watching.